Okay, I think we can start. Yeah, welcome everyone and good afternoon, and welcome to this Prisma CMCC webinar, and that we're very happy to host today. And we're happy that we have with us Jarusch Müßel from the Potsdam Institute, who is has a kind of engineering and economic background, and he just worked and finished a paper and works on transport. So this webinar is on transportation and the transformation of the transportation sector. And I think two very important topics and it's very great to see them together here. One is lifestyle changes and of course technology change, notably electrification of road transport. So we're very happy that he will share with us the latest results and insights on this transition and how behavioral and technology factor matter for this important part in the decarbonization. Let me just briefly go through to explain this series. So this is a webinar series within the Prisma project, which is a project that is funded by the European Commission, going on since 2023. And it has this idea to look at the transition from the emissions in Europe to net zero from a kind of multifaceted angle. I have all the colors here. So we look at the question of justice, finance, innovation, lifestyle, and climate impacts. And here I think this lifestyle factor and sector transition is the important ones featured in this webinar. And we try to really look at how these transition pathways to net zero in Europe and how they can look at these different angles. So our key point is that first, there's a key need for modern innovation. So how we model, for instance, the energy transition on the demand side is important. So there's a lot of models here. You can see all the integrated assessment models typically that are involved, which are quite a lot. And there's a lot of model development going on. Also, I think some of which are relevant in this talk. And we also look at specific policies of the Fit for 55 package, right? So the key policies of the European decarbonization policies for the next decade. Yeah, please feel free to tag us or look at our website if you want to know more about the projects or our results. And just for this webinar, so this is a standard, let's say, Zoom webinar. So you can always, let's say, raise your hand if you want to ask a question and type it in the chat box. Or after the seminar, we will also give room for questions via the written, and I will pass it to the speaker. Or you can also, I can give you the floor if you really want to discuss a bit more and speak up. With that being said, yeah, very happy to have you here, Jarusch, for today. And I'll share my screen and you can share a presentation. I would suggest, yes, as we discussed, half an hour, 35 minutes of presentations. So we have enough time for questions and answers, discussion on this important topic. If you have questions, yes, you can use the Q&A box. Thanks a lot and see you after the presentation. We can see it perfectly.
Yeah, perfect. Thank you for the introduction. I hope you can hear me also now as well. Thank you, Johannes, for the introduction. Thank you for taking the time today to moderate this session. Thank you, Sophia, so much for organizing this, and yeah, CMCC for organizing and distributing this. Yeah, half an hour, 40 minutes. Let's jump right into it. I'm Jarusch from the Potsdam Institute for Climate Impact Research, and this talk today is on different solutions for the transport transformation. And there we will focus on 3 scenarios, and the main focus will be on electrification and lifestyle changes and how these impact climate mitigation, but also non-climate externalities. This talk is based on a paper that got recently published in Environmental Research Letters. If there are any additional information that are required after this talk, yeah, please feel free to check out the paper. I would say the supplementary information is quite extensive. So yeah, I hope that there you would also find a lot of answers even after the talk. Let's get a very broad start into the topic and then narrow it down to what we did in the paper. I'm just talking now about different entry points for transforming the transport sector. And yeah, what are we transforming then? We are transforming a sector that is very much based on cars. In Europe, we have almost 90% cars in our modal split. The transport sector is pretty relevant in terms of climate mitigation, 25% of end-use sector emissions, and almost 20% of total global emissions. Yeah, so significant. And in particular in the transport sector, in comparison to other sectors, maybe building is a similar case. There, since 1990, the emissions are flat or rising, depending on the region. And this will probably still remain the case, in particular due to economically developing countries that now experience a rise in GDP per capita. And with this, the emission intensity of their transport system will probably increase. And lastly, I will talk a lot about climate, but there are other externalities, for example, accidents from cars, air pollution. This is less a topic in Germany, but more, for example, in India. Yeah, so I will also focus on this. If we very much stay in our current transport system and don't think about a lot of end-use transformation, then one obvious thing we can do to limit emissions is to just do the same things, but a little bit more efficiently. So drive our cars more efficiently, or put more efficient combustion engines into them. If we then also think about like a little bit more drastic change, even though they're not that drastic, I would say we can think about electrification. So you still use a car, but it's an electrified car now. Or we can think about changing our modal split, changing our transport mode. So instead of here, let me try and get the laser pointer. Here, instead of using the car, using alternative modes, so public transport, shared, pooled mobility as a service solutions, efficient things like this. Those solutions usually have bigger potentials in urban areas. Exactly. And lastly, if we now look at here at this example of the airplane, which is way more difficult to substitute. There we have either a technological solution of sustainable aviation fuels, though they are pretty scarce. And then in some situations, there will be, or there is the option to just don't do your flight. Maybe there's the potential for virtual connectivity, that you do a Zoom meeting as today, for a business meeting. Yeah, so of course there are more things you can do in the transport sector, but I wanted to give one maybe comprehensive picture that shows the different dimensions, because there are different dimensions to organize all the things that can be done in the transport sector. It's important to cluster them. There are frameworks that already exist, the so-called Avoid, Shift, Improve framework. It's quite an established framework, but in our talk, or in our paper, we used a different framework because we feel that in some publications, electrification ended up in shift. So maybe that was not super clear for people, but the biggest reason for using electrification, lifestyle changes, and efficiency improvements of already existing technologies is that here, electrification and efficiency improvements, which they don't exclude each other, but you can use a focus on efficiency improvements and maybe later alternative fuels as a counter argument for electrification. So we thought it makes sense not to have them in the same category, but rather put them in our new clustering. And along these clustering dimensions, we will we created scenarios. And so these scenarios include electrification, lifestyle changes, so changing the modal split, and sometimes just doing less mobility. So, for example, for international aviation, there are not that many alternative transport modes, especially, for example, for a transatlantic flight. But for the car, there are alternatives. And these are considered in our lifestyle change scenario. And then we have the efficiency scenario with a clear focus on efficiency improvements in already existing technologies. So we will assess these scenarios in terms of greenhouse gas mitigation, but also in other dimensions. I will later show you the exact ones, but just to broaden the picture a little bit, what you could also focus on, specific things like air quality, but also things like more efficient cities where congestion is not that high, more livable cities. This is a very broad term. It's difficult to find a good proxy for this, although we tried in our study, and then just human health. And this is what we did. So the two research questions that we answered, or hope that we answered in our paper, what are the climate change mitigation potentials of our three different scenarios, and what are the non-climate mitigation potentials, or for the non-climate externalities? I will quickly go through some definitions, bunker fuels and lifestyle changes, give you a short overview over our model, though this will be very short. If you have additional questions, please feel free to ask them during the discussion. Then I will briefly explain how we translated scenario results into costs for the respective externality categories, so costs for accidents, costs for climate change. Then I will show you all the results based on these two method blocks, give you some final conclusions, and then I'm very much looking forward to our discussion. So I will use the term bunkers or bunker fuels, bunker sectors throughout this talk. What I mean by this, I mean with bunker sector, the sector international aviation and maritime shipping, which is treated differently or separately from domestic aviation and navigation, and of course also land-based transport. And it's very important to do this because the magnitude of especially maritime shipping is, it's in another order of magnitude in comparison to these other modes. And these sectors have specific characteristics. One is, for example, that technological alternatives and transport mode alternatives are quite scarce in these sectors and not really available. I gave you this example of the transatlantic flight earlier. It's difficult to use there an alternative mobility as a service category like car sharing or whatever. So yeah, these are treated separately because they have their own dynamics. And then lifestyle changes, I feel that this term is used in very different ways. In our scenario design, lifestyle change activities include all behaviors that reduce the energy demand of motorized vehicle kilometers. So if you increase your cycling behavior, then this is a lifestyle change. It increased vehicle kilometers, but it did not increase motorized vehicle kilometers. If you then even substitute your car with that, then you even decreased motorized vehicle kilometers. So there are certain things you can do more of, more public transport, car sharing, carpooling, active mobility, because all of these go hand in hand with a decrease in motorized vehicle kilometers. So usually more public transport means less car kilometers. And for this demand here, less aviation, this either means more high-speed rail or just less aviation. For all the different demand-side mitigation measures, so more public transport, more active mobility, more electrification that we will look at, it's always important to choose the right degree of this change, the right intensity for it. And with our scenarios, we try to choose the similar amount or of intensity. It's very difficult to do. We use literature values and then focused more on the upper bounds for this. But this is just something to keep in mind. We thought about this, but yeah, it's very good, very difficult to ensure that you always chose the same amount of intensity here for the different scenarios. Information on this can be found in our supplementary information, where we provide all the literature that we use to make our assumptions. Let me quickly go again into the lifestyle change scenario to show the effect of a modal shift and the effect of just reducing energy service demand. We have here on the left the reference scenario, then we have only demand reductions. So this is mainly a reduction in 2050. You can see this here in international aviation, the red one. And then we have the third scenario is demand reduction plus a modal shift. There you can see demand reduction and then also a modal shift. So we have less cars here and more buses. So the modal shift was from cars to buses. That's just as one example. Yeah. And here I just put this into perspective. We look at different modes here and on the energy service demand again. And we have our reference, lifestyle change, electrification, efficiency, and all combined scenario here. And in the lifestyle change and the all combined scenario, there you see the reduced energy service demand, which comes from a modal shift and actual demand reduction with a focus on the international aviation. So coming from the modal split, we focus on technology shares or fuel shares. Here we have again all our scenarios from reference to lifestyle change, electrification, efficiency, and all combined for different years. 2020, here everything is the same until 2050. And as you can see, we have, especially in the passenger sector, a lot of electrification, pretty much in all scenarios, because we are looking at the European Union with quite ambitious targets when it comes to electrification and quite some remaining bunker fuel demand, which mostly stems from maritime shipping. Highlighted these points here as well. If you would like to discuss this already deep electrification in our reference scenario, I'm happy to do this during the discussion. I have a graph on this. This is just because we chose the EU. I would say in other regions where electrification goals are not that ambitious, the additional impact of our ELEC scenario would probably even be higher. So what model do I use for this? I use the integrated assessment model REMIND and EdgeTransport. Our transport simulation model is part of this integrated assessment modeling family. I won't explain the whole IAM here, but transport is one of the demand sectors. We also have buildings and industry. And REMIND tells transport about very aggregated energy service demands for international passenger demand and short and medium passenger demand, and the same for freight. And that's it from REMIND. It also provides fuel prices. But then EdgeTransport starts, and EdgeTransport then has way more detail on available technologies and on available modes. And then runs a logic-based simulation approach to calculate the modal split, how many cars, how many domestic aviation, how many kilometers of active mobility, and calculates the technology shares. So how many EV sales do we have in 2030, 2040, 2050? That's the same fuel prices and energy service demand. And HT then, if you have the modal split and the fuel shares, you can HT then feeds back to remind the demand for these fuels, the demand for electricity, the demand for gasoline, and then remind runs one more optimization step for the energy supply sector. So that's it. If you have more press questions, please raise them during the discussion. I have some slides on this, but I think for now that would be too technical. Now we're at the point that we run or already ran EdgeTransport coupled to Remind for our 3/4 different scenarios, the all combined scenario. And then these scenario runs are done. And now we look at the method for our post-processing, in which we value the costs for the different externalities. So what I show you now has no feedback, no impact on our scenario results in terms of energy service demand, on emissions, on modal split, on technology choice. This is now already done, and it's just the post-processing. So for our different externalities, we have costs and benefits, mostly costs. And for the costs, we use the handbook on transport externalities from the European Commission, a great source. I'm very happy as a researcher that this exists. Because as you can imagine, it would be quite an endeavor to come up with these valuation approaches all by yourself, and it's great to have a source that combines a lot of different cost factors for different cost categories. What we do is very straightforward. We take our mode-specific energy service demand and technology-specific energy service demand, so the demand for electric cars in this case, for example, and the cost factor for electric cars, for accidents, for air pollution, for noise pollution, for all the costs that we look at. And then we have the costs for, if you want to aggregate this here for electric cars, or if you want to aggregate by the dimension, if you sum up all the energy service demands for accidents in general. So here, just an example, we have cost factors for electric cars, accidents, air pollution. And here, for example, the difference between electric cars and internal combustion engines for accidents is the same, because the assumption is if you get hit by an EV, although it's a little bit heavier, or an internal combustion engine, it's the same. But for air pollution, yeah, the electric car wins because the electric car has no tailpipe emission, only emissions from tire wear and brake wear. So for the benefits, it's a little bit more complicated. I won't go too much into detail. We use the World Health Organization's heat tool in the version 5.3.0. This is an API which you have to program the connection by yourself if you want to feed in your own scenario results. If you just want to play around with it, I can very much recommend it. It's a very nice user interface and easy to play around with and get some first intuitions. But we feed it in our scenario-specific energy service demands, and then I mostly use the standard parameters, but there are some important things to keep in mind. And those are the value of a statistical life, which I did not change, but which very much impacts the results, social cost of carbon, and for example, the assumption that there is no substitution of physical activity. So this tool focuses on the benefits of active mobility, and there the assumption, or this means that if you drive with your bike to work instead of using your car, that you will still go later at night to the gym, and do not substitute going to the gym with going to the bike to work by bike. And then we have the mortality rates. Those you can also to some degree choose, or the parameters for this. I would say these are the most important ones. There are more assumptions, and all of them are listed in our supplementary information. Okay, then we're done with defining necessary terms. I gave a quick overview over the situation of the transport sector. You learned about how the scenarios look like, how the model looks like with which we run the scenario, and after we run the scenario, you learned about our post-processing in which we translate energy service demands, for example, for electric vehicles, into costs for accidents and other non-climate and climate externalities. So let's look at this graph, which you already know. This is again the energy services, and quite interestingly, even though electrification is quite high here, if you then look at final energy demand fuel shares, the electrification share reduces to some degree. It's not as pronounced as here. I mean, of course, for one reason, because this is freight, this is passenger, and this is everything combined. But the other reason is that every kilometer in energy service demand that where you substitute liquids with electricity, you will end up with having a lower final energy demand for electricity, because electricity also has huge efficiency gains. I feel like this is another good reason not to, or rather to use our scenario framework, where we differentiate the efficiency improvements of already existing technologies from the electrification, which has its own efficiency improvements embedded, just because an electric car is more efficient than an internal combustion engine car. So here you see lower shares of electricity than in the energy service demand variables, but still you see quite a significant increase, especially in our electrification scenario here. And you see that bunker fuel emissions remain quite high, and that the biggest reduction is here in our lifestyle change and our efficiency scenario. Which makes sense, because bunker sectors cannot really be electrified. Those are our hard to electrify sectors. So the electric scenario has no real lever on these. Let's look at emissions before we looked at final energy demand. And here you see again our scenarios in the already known order for the different years. And now you can see the emissions from the different modes for non-bunker sectors. And as you can see quite clearly, we already have significant reductions in our reference scenario, but even more significant reductions in our electrification and our all combined scenario. Lifestyle changes and efficiencies mitigation potentials for non-bunker sectors are similar. And yeah, the main message here is electrification is very effective for non-bunker sectors. And the biggest levers for electrification is the mitigation of road emissions and from freight in dark blue and from passenger road in light blue. Now we have the same emission picture for bunker fuels, and there you see that electrification does not really help so much, but lifestyle changes and efficiency improvements have a way bigger impact. In purple, you see freight, and in blue, passenger international aviation. Now, let's go from the emissions to the costs. And here you see the costs for the different colors show you the different categories. So cost for accidents, congestion, air pollution, climate. There are various emissions included, also scope 2 emissions, costs for noise, habitat damage, and other well-to-tank, non-climate well-to-tank emissions. And I chose on the x-axis the most important modes, not to distort the picture. and these are our road technologies. So accidents have the biggest part for cars, and congestion is the biggest part for trucks. And these two are the biggest cost categories overall. So, and those are mainly associated with cars and trucks. I mean, trains can also hit people, but this happens way less often than, yeah, that's happening on the streets with cars. Air pollution, to my surprise, is not as big as pronounced, but I think if you would do the same study for India, for example, then the picture would be a little bit different, though congestion is also a big topic in India. Yeah, but I think air pollution would be a little bit higher here. So now I show you the reference scenario, but in 2050, and you see an increase, which makes sense because over time people still get richer, and this means in our model a natural shift towards faster transport modes, and those are usually coming from public transport or active mobility cars. So yeah, it makes sense that if you have more cars, you have more costs from cars. And then we have all our other scenarios. And as you can see, electrification reduces the emission part a little bit here with climate, air pollution. But yeah, on accidents and congestions, EVs cannot change that much. Same for efficiency. So here only lifestyle changes have a significant impact, cost reduction impact. Okay, now we looked at the costs, and we will continue doing this, but now we also look at benefits from active mobility. On the upper hand, I show you the absolute impacts in 2020. So the society here is happy about people walking and cycling because this decreases the risk for cardiovascular diseases, it decreases the risk for diabetes type 2. And this is, yeah, the society is not moving enough. We're sitting too much. So every kilometer walked and every kilometer cycled is very important, and yeah, has a huge benefit for our society. And then this is displayed in negative cost terms, and in positive cost terms, we have the graph from before, just horizontally now. In 2050, I show you the differences to the 2020 reference value. And there, as before, you saw that the reference costs in 2050 were a little bit higher. So you see here a positive, the ref 2050 shows up on the right-hand side on the positive values. So we have less benefits from active mobility because less people use a bike and more people use a car. So we have less benefits from active mobility and more costs from cars, for example, in terms of congestion and accidents. And then we have our other scenarios, and there again, you can see that the lifestyle change scenario has shows significant improvements, especially because people cycle and walk way more in this scenario. And this is very valuable for our society, not so much in terms of climate mitigation, but just in terms of general human health. Maybe to focus on some numbers here, lifestyle changes on this graph, because the numbers are not perfect, cannot perfectly be seen. Reduce the adverse externalities of motorized modes by 30%. Lifestyle changes increase by more than 50%. Meaning that the total positive impact of increase in benefits and a decrease in costs, in this case for Europe, is about 70 billion euros per year in 2050. I would say just this number might be not correct if you focus on €1, but it shows the general dimension of this. Probably an integrated assessment model is not the right tool to focus very specifically on air pollution and health benefits in one city because we don't have this granular resolution, but it can show the average effects and the overall direction. And I feel like this gets quite clear already from this graph. If you want to have like numbers that are more exact, then you would need to do case studies, and this then very much depends on the specific conditions of each city, I would say. But happy to discuss this very much later. What I can say is that our results are pretty much in the middle of the peer-reviewed literature and gray literature. We have about 50 cents benefits per active kilometer, and the gray and peer-reviewed literature goes from 30 cents per kilometer to €1.60 per active person kilometer. So we're pretty much in the middle there, even at the lower end. Okay, these are the results, and now I just quickly conclude. I will briefly go through our limitations or potential system limitations on the scenario design. Just keep in mind that this is a model and our scenario results depend on our input assumptions. We tried to be very transparent about them and listed our literature that we used in our supplementary information, but I think it's worthwhile noting. Then we have normal model limitations. We only model to some degree explicitly and sometimes not at all the impact of infrastructure investments, regulatory interventions. We cannot model every law, and we don't model a broader change in values, behavior, and norms of a society. This is especially important for the lifestyle change scenario because this is not a low cost, a zero cost scenario. You cannot just say as a politician, now we go for the lifestyle change scenario. There would be changes in infrastructure and investments needed to make cities more walkable, to make public transport more attractive, and there would be some political impact or political capital needed. Then we just have an average agent, so we don't have heterogeneity in terms of age, income, so everything is averaged in our model. And so, example, for our urban and rural assumptions, we use urbanization shares to do this aggregation. Limitations on our post-processing, because it's just a post-processing, this is not related to our model anymore. And I did not invent the methods. I very much use the values from the European Handbook on Transport Externalities and the HEAT tool 5.3.0, made some slight adjustments, but yeah, if you take our results, you buy in some limitations or especially the assumptions of these sources, for example, in terms of value of statistical life, social cost of carbon, and mortality rates. So final slide on conclusions. In terms of climate mitigation, it's clear for non-bunker sectors, electrification is the most effective strategy. It has the highest potential, but limits to the hard to electrify sectors. It requires large investments in infrastructure and change of a transformation for the end user. Lifestyle changes have synergies with the electrification scenario because they can mitigate emissions where the electrification scenario cannot mitigate in the hard to electrify sectors, and lifestyle changes are associated with less inertia. So high electric vehicle shares are great, but the electric vehicle fleet or the vehicle fleet overall is very, very big. And even though if we have high electric vehicle sales shares today, it still takes some time to turn over the whole fleet. If people just change their behavior, like from today to tomorrow, this could have more of an immediate impact already. Efficiency improvements have also significant mitigation impacts, but they are more associated with a carbon lock-in. because at the moment you don't change anything and you just rely on huge efficiency gains and later the upscaling of e-fuels. So if this doesn't come, if this comes too late, there's a risk of a carbon lock-in, because here the burden is on the supply and not on the end user demand side. And on external costs, it's very clear only lifestyle changes could reduce our cost drivers. The biggest costs come from congestion and accidents, meaning from cars and trucks. And the improvements in well-being in terms of activity benefits are very big. Those come from cycling and walking. And with this, thank you so much for your time. Looking forward to the discussion. If you are interested in the paper, it's open access, you can just read it. If you have questions, feel free to email me. And as I said, additional information can be found in the paper and especially in the supplementary information. Thank you.
Okay, thank you a lot, Jarusch. Great topic, great presentation. Also for taking the time. So yes, thanks a lot. So please feel free to put a question if you have in the chat. There are already 4 or 5. Let just one thing. So we hopefully will also share the presentation with the YouTube registration. I think that's okay. That was the first question. Yes, one question on the wording also, SAF, right? The fuels that you mentioned. So that it's important to avoid greenwashing there. Maybe that's a very contentious topic. One question maybe to you. So how to deal with the rebound effect? That is, of course, something that's been discussed often in the relationship to efficiency measures. Is that included in the analysis, especially on the efficiency scenario, maybe? A potential rebound effect.
Yeah, we did not quantify that, so I cannot say how big it is, but in general, it should be captured to some degree in the way REMIND is set up. If you run REMIND, our big integrated assessment model, right, let me just go back to this one slide that might help a little bit. REMIND and EdgeTransport run iteratively, then they talk to each other. HT gets the fuel prices and energy service demands, calculates the modal split, and feeds back demands for final energy carriers. Before REMIND's so-called SES tree is set up, one run of EdgeTransport is needed, and this run, we also have a standalone version, and this is run using the EdgeTransport 10 standalone version. And the parameters of this REMIND SES tree change depending on how REMIND is calibrated, which scenario you use. If you use the lifestyle change scenario, you get more energy service demand from transport using less final energy demand, or it gets less, or no, take the efficiency scenario. If you there calibrate REMIND, then REMIND sees, okay, transport got a little bit more attractive because I get more energy service demand for putting in less money or less final energy carriers, and then REMIND will just put a little bit more energy service, shift it to the transport sector on these very aggregated nodes, which are shown here, because these are the nodes that REMIND sees, and then there are all the other nodes that come in that only EdgeTransport sees. But these nodes would get, in comparison to buildings and industry, more energy service demand from REMIND because transport just got a little bit more attractive during the calibration process. But I didn't quantify this, so I cannot say sadly how big our REMIND effect is. Yeah.
But partly it's covered. Yes. Okay. Okay. Then another point on the general question for this series by general. Then of course, it could be also doing some Q&As or online tool. That sometimes we do this sometimes in these webinars, to be honest, but it depends on the format. Typically, these Not all topics are equally suited. Sometimes we do that, but yes. Not the case, but yeah, feel free to put questions, and you can, of course, upvote questions also. Another comment on environmental psychology, also with 2 links that you can also check out later. So the role of environmental psychology and how to induce these behavioral changes, I think something, yes, also very important, of course, right? So how you had some specific calibration, I understand it, right? But did you discuss this or think about this topic, or what is your take on this question of more psychological angle of behavioral change?
Sorry, I only saw the Q&A now. Which question are we talking about?
The fourth one by Carla on, but just in general, that the 2 links that you can check out later, just saying that, well, the psychology of this behavioral change is very important, and I fully agree on that. So just maybe if you have some thoughts on this.
I will answer a little bit, but please direct me if you feel I missed the question, because I didn't find it directly. Maybe this is interesting. So we think about this, but the model cannot capture this perfectly. Let's be very honest. I will quickly discuss how edge transport makes decisions or calculates the share, the modal share and the technology share. And this is in general a price-based decision. And the price here consists of fuel cost, non-fuel cost, and the value of time. So a very slow transport mode like walking would have high costs, so the share wouldn't be super high. Then we have this exponent. This shows to some degree the stickiness to this mode. If another mode gets cheaper, how willing are people to shift to that mode? And then this is like the important one, which captures everything, is the preference factor of the people. It's calibrated to historical demands. So let's say we compare buses with cars. Then probably for German, a car-loving country, this preference factor for cars is quite high, and for buses it might be quite low. So things like this are captured in our model, but in a very stylized way, being honest. And we then later can use the basis of this preference factor, the trajectory, and change this to say, by communication campaigns, by changes in infrastructure, which we don't model, this preference factor for cars decreases and the preference factor for buses increase. But this is what I meant when I said the lifestyle change scenario is not a zero cost scenario. There are costs associated this increase in preference factors, but those costs are not present in the model, because you would need to change cities to make public transport more attractive, more walkable. One thing to mention for electric vehicles and internal combustion engine vehicles, that we don't have this preference factor just for this competition, ICEs versus electric vehicles. There we use explicit inconvenience costs, and there are costs, for example, associated with range anxiety. And there's a dynamic in the model that when we have higher shares of electric vehicles, then the range anxiety decreases, because if you're the first one having an electric car, probably there won't be any charging stations. But if everyone has an electric car, the assumption in the model is that there will be a lot of charging stations, so range anxiety should not be such a big issue anymore.
Yes, good points. Maybe as a related question, do you consider demand reduction based lifestyle changes? Like Vera asked whether you look into, for instance, working from home could reduce demand allocation, increased urbanization. These kind of trends, are they considered or as a kind of baseline driver or demand reduction?
I mean, baseline drivers are considered as part of the shared socioeconomic pathway that we use. This pathway is then associated to trajectories for GDP per capita, for urbanization, but this is nothing that we actively use in our scenarios, this SSP dimension. And then we have our different demand side interventions. So for example, a reduction in international aviation. And this is one specific lever where we read literature on it and reduce this value later in the model. So for some modes, we considered this, and I would say the most important one is international aviation. And there I would say the driver is either people use make less holidays using going from Berlin to Rome. This is also already international aviation. Or for a meeting like this, that people just do more Zoom meetings. So these are the two drivers, I would say, for a reduction in international aviation. For like cars, I mean, there it's more about the modal shift because just by making public transport and car sharing more attractive, thereby we already reduce car kilometers, but we don't reduce person kilometers for road demand. Yeah.
Okay. And on the impact side, the question by Carla on the health effects, do you include PM or PM 2.5, PM 10 impacts? I assume so on air pollution. But
Yeah. I mean, what do we have here? Air pollution. Yeah. Being honest, I'm not an expert on the calculation of the cost factors in the European Handbook on transport externalities. So my expertise comes from reading this and talking to a handful of experts that use that and that helped me like with refining their cost factors, their assumptions. But in the supplementary information there, I wrote down everything and in more detail that probably I can recall now, but we have the different types of PM, particular matter, which is considered in our air pollution calculation. And so, for example, I cannot recall, the one part is 0 for EVs, but other particular matter dimensions are high and sometimes even higher for EVs because EVs are heavier, the brake wear and the tire wear is higher. So in this dimension, this is why the cost factor, for example, is not 0. In the supplementary information, I explained it, but I cannot really recall the exact numbers right now.
Yes, makes sense. Thanks. Another question on whether by Marco, whether this analysis could be also applied to a more local context, let's say to a city or a region. But I say yes, like.
Yeah, well, I would say in general, yes. Our IAM has not the city granularity. If you can downscale our results to a city level, then you could very much use the tools, especially for the health and externality assessment, because the European Handbook divides then also in urban and rural areas for the different countries. I used quite aggregated values, but these tools provide way more granular data, and especially the heat tool for the activity benefits. This is some cities are not included. Then you would just need to choose a city that's maybe similar to the one you're doing research on, but this goes down to the city level, and it's crazy how much detail is in there. I only use part of the information because the IAM is so aggregated.
But you could do it at a local level with local data, but if you had them,
if you have them, yeah. If you have them.
Okay. And then two other questions by Viswantan. So you talk about this deep electrification, especially on individual transport. Is it also, do you also apply it to public transport, especially buses? Which
Yeah.
of course. So you have this, okay.
It's electrification is high and for all the modes. So it's not high for international aviation because there we say it's not possible to electrify, but for buses, for mopeds, for cars, in some regions rail is not at 100% electrification. So even there we increase the electrification share.
Okay. And what source is the primary energy? Is renewable or conventional, or is this depending on the model run?
That very much depends on the model run. We used always the same kind of model setup for the whole IAM. So it's always in our speaking, it's called NPI, national policies that are already implemented. So it's like a medium ambitious scenario, and we have the demand side in our IAM, so buildings, transport, industry, and then we have the supply side. And for the power sector, we have different generation technologies. So I don't have a slide sadly on the fuel mix, but for Europe, electrification or renewable electrification is quite high, I would say, in comparison to, or like medium high in comparison to other regions. So if the question then points to scope 2 emissions, of course there are some. We still have coal and gas, but it's not super dirty. So like the results hold still true when focusing also on scope 2 emissions. Yeah.
Okay. And yes, there was the last question, but if you have, please have a question, please go ahead or raise your hand. Don't be shy. Please explain your sampling strategy. I don't know what it refers to, maybe the uncertainty around the data, or also when you look at Europe, only global, I mean, full European level data, right? But you have the data also at country level, I assume, or in case you have some uncertainty quantification.
I'm not sure about what sampling strategy means, but REMIND has, I think, 9 different regions in Europe. So, for example, Germany is one, France is one, and then we cluster other regions. Regarding our then specific assumptions, for example, reduction in international aviation, this very much depends on the source that we looked at. So I think for this we had a source on Europe in general. So this is not a German specific assumption, but for example, our load factor for cars, those are then Germany specific and France specific. Yeah, so that depends a little bit on the transport mode. Yeah, but as I said, I'm not sure what sampling strategy means. Please feel free to drop an email if I didn't answer any of your questions completely.
Okay, great. Thanks a lot. Thanks a lot, Jarusch. It was very nice, very insightful. And also saying that, well, 100 billion euros of gains every year just because we walk and bicycle, basically, right? That is what this graph is saying. Yeah. So in that sense, let's move a bit after sitting in front of the screen. Thanks for joining today, and yeah, it was a pleasure to have you. The paper, I put the link in the chat if you want to check it out, but we'll also publish it on the YouTube channel of CMCC along with the presentation if Jarusch agrees. And yeah, looking forward to the next one, which will be coming up in a month from now, I think. And yeah, have a nice rest of the day, everyone. Thanks a lot to Jarusch, and see you next time. Thanks a lot.
Yeah, thanks for all your questions, and thanks so much, Johannes, for taking the time, and Sophia for organizing this. Have a great day.